Okay, for number one, they say a two-digit number is 4 times the sum of its digits. So the first thing, right, so this is number one. The first thing you have to understand when we talk about a two-digit number. So if I wrote the number, 52, the value of the digits 5 and 2, the value of this number is 52, and we just became accustomed when you see a 5 followed by a 2 to say 52. But in reality, the 5 is in the tens place, so it's really 5 times 10, and this is 2 times 1, right? That's the ones place, and we add these, right? So we would get 50 plus 2 is 52, right? So that's really what we're doing. If we had a three-digit number, which was like 135, we're so used to saying 135, but this is really 1 times 10 squared, or 100. And this is 3 times 10, which is 30. And this is 5 times 1. And we add all those, 100 plus 30 plus 1, or plus 5, and we get 135. So for these problems, you have to understand when we talk about the number, we're talking about the value of the number. So what I like to do is I like to read the statement and just write mathematically what it says. So it says a two-digit number is. So a two-digit number, they're talking about the value of a two-digit number. So I'm going to let X represent the tens digit, and I'm going to let Y represent the ones digit. So the number is going to look like this, right? XY. But if I wrote XY mathematically, it would mean X times Y, so I can't do that. So it says a two-digit number. So the value of the two-digit number, remember, this is X times 10, right? And this is Y times 1, right? So when it says a two-digit number is, what they're really saying is 10x plus y, right? That's 10x plus y. That's the value of the number. That's equals 4 times the sum of the digits. The digits are x and y, so the sum of the digits is x plus y. So that's the statement. Then the second sentence says the tens digit, which is x. The tens digit, x, is equals 3 less than the units digit. The units digit is y, and is 3 less than that is written that way. So there's our system of equations. So this first equation, let's simplify this. I'm going to kind of go to the right because I'm out of space. I'm going to run out of space lower. So this becomes 10x plus y equals, and we distribute the 4x plus 4y, right? And now I can bring the 4x to the other side by subtracting. We get 6x plus y equals 4y. And then I could subtract y from both sides and get 6x equals 3y. So this equation is this. So the two equations are really 6x equals 3y and x equals y minus 3. So to solve this system, I'm going to use substitution. I'm going to take the y minus 3 and put it in this one for x. So I get 6 times y minus 3 equals 3y. 6y minus 18 equals 3y. I'll subtract 3y from both sides. So 3y minus 18 equals 0. Add 18, 3y equals 18. And divide by 3, so we get y equals 6, right? Okay, y equals 6. And now we need to get x, right? So I can take, for instance, this equation and figure out x, right? X equals y, which is 6, minus 3, so x equals 3. So the number, remember, the number was this, represented as x, y. So the answer to this problem is x is 3, y is 6. So the answer is 36. And if we read through the question, it says a two-digit number is 4 times the sum of its digits. The sum of the digits here is 9, right? and 4 times that is 36, so that works. And then it says the tens digit, which is 3, is 3 less than the unit digit, which is 6, so that works. So 36 is correct.